got up at 4:30 this morning just to shoot this video. By the way, big, huge shout out to Hilton Boys Soccer. First time in 28 years. You can call yourselves sectional champions. I'm so proud of you guys, man. Yes! What a run. 4 shutouts in sectional games. Not a goal scored on Brian Wilkin. Yes! Congratulations. Now let's do it in the States, boys. All right. But, you know, if it's 4:30 in the morning, gotta have my coffee, because otherwise, it took me a long day. I think I might grab a little Dunkin' Donuts on the way to school today, too, guys, just to be a little bit more amped up for school, because you can't get amped up enough. By the way, if you're watching the videos and you haven't hit the subscribe button, shame on you. Help me out a little bit. Subscribe. Hit a couple of my commercials and my ads. If something pops up at the bottom, there's an X. You can hit the X and get rid of it. Or if it's something that's so cool that you just have to have it, you can click on it. And I think a little revenue comes my way. Last and not least, there's a little thing up there in the top left somewhere. Yeah, it's over there somewhere. I don't know where it is. That says you can donate to my cause. I'm going to probably start a GoFundMe page, because if I have to deal with this laptop much longer, I'm going to throw it out the window. Just kidding. All right, kids, this is Unit 3, Day Cuatro. Tomorrow is Cinco. No, just kidding. That'll be over the weekend. Anyway, let's get going on this thing. Let's see if Mr. Key can come out, because I'm not sure how this computer was acting up before I got on here, which is why it's like 5 o'clock instead of 4:45. Plus, I had to take a shower, dry my hair, get it all gussied up, get my grill all cleaned up before I get on the video. I want to look sharp. So let's see if we got this thing working. Oh, looks like it might be working again. Yay! Mr. Key is back. All right, you are going to ride with me on this completing the square notes for a while. Okay, so let's first talk about simplifying radicals. You know, we did this already, right? We break it up into a perfect square. And then we say, oh yeah, square root of 16 is just 4. By the way, it's just 4. It's not take the square root of 4 again. I know you're like, oh, but 4 is a perfect square. And every time I see a perfect square, I just want to take the square root of it. It's like every time I see Ted Lawson, I want to yell out, awesome, awesome, 40! Probably should have said his name on video, but he'll get over it. He'll get over it. He's the man. Man on crutches. Just kidding. All right, real quick, let's do a little quick review. Square root of 24, we can rewrite this as 2 radicals, or as radical 4 times radical, times, let's make this a 6. 4 times 6 is 24. The square root of 4 is 2, so this just becomes 2 square roots of 6. 56. Well, 8 times 7 is 56, but neither one of those is a perfect square. But I can do 4 times 14. Square root of 4 is 2, so this gives me 2 square roots of 14. Now, someone's like, how did you get that? I don't understand. Well, I can do it like this. Let's say you're not very smart. You can't figure out the perfect square that goes in there. I'm just kidding. Not trying to bust your self-esteem. I just haven't had enough Brugger's coffee to make me happy. So I might make fun of you a few minutes, and then when I drink my coffee and I get happy and I go crazy, then you'll be excited, and then I'll be happy, and then I'll be nice. I don't know what I'm talking about. But let's say you're saying, okay, I know I need a perfect square, but the only thing I can think about that multiplies to 56 is 8 times 7. Okay, start with that. And then say, okay, 8's easy. I know 8 is 4 times 2, and then times 7. Because this is the 8 times 7. And you're like, okay, 2 and 7 don't have a perfect square in them, so the only perfect square must be 4. So square root of 4 is 2, and then I end up with 2 square roots of 14, because 2 times 7 is 14. Another way to do it. 18 is easy. It's the square root of 9 times 2. Square root of 9 is 3, so 3 square roots of 2. 72 is a lovely one. We love to put 72 on there because every kid goes, oh yeah, that's 9 times 8. But wait a second, 8 has a perfect square on it. So it's really 9 times 4 times 2, right? So this is 9 times 8. Now, 9 times 4 is 36, in which if you got the right one the first time, you would have said 36 is the perfect square. So this is 3. This is 2. So my final answer is 6, because you multiplied 6 square roots of 2. Now, had you picked the 36 times 2. You would have gotten there quicker, but it doesn't matter. You can still get there. 112, I have no idea. So what I'm going to do is I'm pretty sure 4 goes in. So let's see. 4 goes into 100 25 times. So this would have to be like 28. But wait a second. 28 has a perfect square in it. 4 times 7. So this is really 4 times 4 times 7. So had I picked the largest one the first time, I would have gotten 16 times 7. But I didn't. It's not a big deal. This is 2. This is 2. So my thing is 4. By the way, we're multiplying, not adding. 4 square root of 7. In that case, kind of didn't matter. All right, guys, if it's got a 75, 25, or 50, you know 25 goes into it. And this is the square root of 25 times 7, which is 5 square roots of 7. I'm just rolling now. 300, I have no idea what goes into 300. Oh my God, it's 300, maybe 25. Oh, 25 goes in. It's 100, kids. 300. Of course, 100 goes in. Square root of 100 is 10. So this is 10 square roots of 3. 128. I'm going to guess 64 times 2. And the square root of 64 is 8. So it's 8 square roots of 2. Okay, just a little review, a little warm up on those. Now let's talk about completing the square. We want to make sure a is 1. We're going to take half the middle and we're going to add it to both sides. And by the way, since we're squaring it, it's always positive. I forgot to say we got to square it there. Square it. It's always positive. Factor, square root, solve for x. And don't forget when you take the square root that you must have a plus or minus. I should have added that there. So, first rules first. Got to have a equal to 1. In this case, a does not equal 1. Oh, you don't like this here? I don't like it there either. Let's move it over because I don't really like it there. It's annoying. So let's get a equal to 1. Divide by 3, divide by 3, divide by 3, and divide by 3. And yes, you must divide both sides. Both sides by 3. Both sides by 3. So I get x squared plus 12x plus 14 equals, well, 0. That's easy. So, all right, I missed a rule. I don't know if what happened. Okay, so I don't like the way I wrote these rules up. I'm going to add, whatever. Follow my rules while I'm doing the problems. Constant has to go to the other side, so we're going to rewrite it with 2 boxes. X squared plus 12x plus square, completing the square. By the way, that's not why it's called that, is equal to negative 14 plus square. Now, the reason I put that square in there is because I'm going to fill that up. Now, this is important. We're going to take half of this, bring it over here. Half of this is positive 6. Squared is 36. And if I add 36 to one side, I have to add 36 to the other side. Now, I need the room, so I'm going to get rid of this. No, I'm not. So, now I'm going to factor. X plus 6 squared. Whatever this is the number that's going to go right here. X plus 6 squared is equal to, what was that, 22. Now, I take the square root of both sides. Now, when you take the square root of the left side, the square root and the square cancel. And I got to take the square root of the right side and not forget to put a plus or minus. So this gives me x plus 6 equals plus or minus the square root of 22. Well, I'm not quite done. I still got to solve for x. So most of this is right. I just forgot a step. Solve for x. I get x equals negative 6 plus or minus the square root of 22. And you have to take a look at 22 and see if it can be simplified. In this case, it cannot. All right. Solve by completing a square. First step. First step is to make sure a is 1. It's already 1. So we're going to bring the 28 over and rewrite it. X squared minus 8x plus, it's always plus, because you're going to square, and anytime you square something, it's positive, equals positive 28 plus square. Half of this, now be careful, half of this is negative 4. Squared is positive 16. Positive 16. So I get x squared. Why did I just do that? I forgot. Let's do this in black. So this is going to be x minus 4 squared. Because if I wrote this twice, right? X squared, and then I would get negative 4x, and negative 4x is negative 8x, and negative 4 times negative 4 is positive 16. And I don't want to write it twice because I want it as completing a square. So that's why I just write it as a perfect square trinomial, because this thing right here is a perfect square trinomial. What does that mean to be a perfect square trinomial? That means that will turn into a perfect square, something squared. That's what's called a perfect. That's why it's called a perfect square trinomial. And then this is equal to, what is this? 44. 44. Take the square root of both sides. Don't forget your plus and minus. Everybody forgets those. No, they don't. Actually, most kids don't. They're pretty good about it. Is equal to plus or minus. Now, I know this has to be simplified, so I'm going to take this off to the side. And I'm pretty sure that's the square root of 4 times 11. Square root of 4 is 2. So this becomes plus or minus 2 square roots of 11. And then we're going to toss this thing over and put it right there in front. When it goes in front, it becomes positive. So get final answer is x equals positive 4 plus or minus 2 square roots of double ones. Here we go. Moving on. All right. So first we got to do 2, 2, 2, 2. So I get x squared plus 4x. Now, I'm going to bring this thing over right away. I'm going to do a double whammy here because I like to save time and be lazy. I know it's coming over here, and I'm going to take half of it. It's negative on this side, so it will be positive on this side. And 152 divided by 2 is 76 plus square. So I did a little double whammy step there. You'll deal with it. Took half of it, brought it over. All right, half of this is 2, positive 2. That means immediately this is x plus 2 squared. Maybe you want to write that. Put a 4, and I get equals 80. Take the square root of both sides. Don't forget to put a plus or minus. Square root of 80. Let me bring it off to the side here. 80. Now, for those of you, I only know that 4 goes in. 4 times 20. Oh, crap. 20's got a perfect square. That's 4 times 4 times 5. So if you didn't recognize right away that 16 went in, you can still do it this way. So square root of 4 is 2. Square root of 4 is 2. So this becomes 4 square roots of 5. So now I can come back to the problem. I'm going to rewrite it as x plus 2 equals plus or minus 4 square roots of 5. And that's going to go right there. So I get x equals negative 2 plus or minus 4 square roots of 5. Now, I hate it when I get to a problem. I'm like, man, I wonder, did I get that problem right? I have no idea if I got that problem right. So what we're going to do is we're going to check our answer. So let me get my eraser just for a second. I want to erase this so I can see what my original problem was. Now I'm going to come over to my calculator and I'm going to go into calculation mode. And we said the answer was negative 2 plus, now you can't do plus or minus, I forgot what it was, 4 square roots of 5. And what we're going to do with this is we're going to store it into x. Now it's going to give you some crazy decimal. There it is. There it is. Crazy. And then I'm going to type in my original problem. My original problem was 2x squared plus 8x minus 152. Now if I got this right, it should equal 0 because over here on the problem it said equal to 0. If you got one right, you probably got 2. But you know what? Might want to check it. Just check it. I can come back here and go, okay, I checked the plus. There's like a 99.9999999% chance the minus is going to work as well. Put the minus in. Go up here. Ding, 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 ding. Hit enter. And you're like, oh, by the way, I was hoping that would happen. This e to the minus 11 that shows up, probably my big fat head is in the way, so let me move that over. This e to the minus 11, 1, negative. First of all, you got the 0 there. I don't know if my big shiny head was in the way there. And you got this negative 1 e to the minus 11. That's just 0. Because what that is it's really negative 0.00034, 5, 6, 7, 8, 9, 10, 11, 1. Yeah, that's 0, kids. That's equal to 0. The problem is your calculator approximates. All right, let's keep moving. So sometimes I want to, and this is what we were doing yesterday, and I might switch things. Sometimes what I want to do is I want to take this so I can graph it. So I may want to take this and put this in. I am going to have to switch the order of these things. I may want to take this and put this in, whatchamacallit, what's called vertex form. Sorry, kids, I'm just thinking there's 2 days worth of stuff. I'm doing vertex form before I'm doing completing a square. I don't know if I should be doing completing a square before I do vertex form. I'm going to have to give that some thought. But for now, let's pretend like you know it or don't know it. Okay, let's take a look at this. So, first thing we're going to do is, if we want to solve a quadratic, we can throw away leading coefficients. Like I was dividing by 3, dividing by 3, dividing by 3, all that stuff. But if we're going to want to still retain what the shape and the size and everything of it, you cannot throw away. It's like factoring. When you factor, you can't throw things away. So what we're going to do is we're going to first take the 42 and move it to the other side. For now. Then we're going to factor out this 3 on this side. So 3x squared and like magic, it's gone. I apologize. I had to pause the video. The problem with it was all of a sudden I started thinking, geez, have I done this in the right order? Did I not do this in the right order? And I started doing the problem the wrong way. So let me re-go. What we're going to do is we're going to set this equal to 0. Let me redo this again. Sorry, I had a little brain fart there for a second. By the way, while you were gone, I was hitting the sauce, if you know what I mean. Thanks, Brugers. How about a shout-out, Brugers? Y'all email Mr. Brugers and say, Mr. Brugers, this guy has been giving commercials for you like forever. Makes me want to drink coffee at 14 years old, 15, 16 years old. All right, some of you are 17. All right, so what we're going to do is set that equal to 0. We're not going to worry about this right now. We'll come back to that in a second. We'll bring that back into the show. So we're going to divide by 3. You cannot throw this away. So that was right. I actually didn't screw that part up. But we're going to divide everything by 3. We're going to factor out that 3. So what we're going to do is we're just going to work on this section right here. So we're going to do just this by completing the square. We're going to pull it out and we're going to put it back in. Doesn't really sound right. So, oops, forgot this X here. Yeah, that's right, Goulet. Forgot the X. Jerk. By the way, keep calling me out when I make mistakes. So we're going to bring the 14 over. Negative 14 plus square. All right? Yes, I don't mind being called out if I make a mistake. Forgot an X in class the other day, and this guy in class decided to go, oh, Mr. Krause, could you do problem number blah, blah, blah? I don't understand how you got your answer. And it's because it didn't have an X in it, and so he did it a different way. Ah! Nice job, bro. Nice job. Being a jerk. Oh, did I say that out loud? I didn't really mean to. Oh, my gosh, I was just kidding. Anyway, half of this is positive 6. So let's go through this. Half of this is positive 6, so this is 36. I think we've already done a problem very similar to this. Look back on the other page. And this becomes x plus 6 squared equals 22. Now, here's the cool part. What we're going to do is we're going to bring the 22 back over. So we got x plus 6 squared minus 22 is equal to 0. I don't really care about the equal to 0 now. Now this is really that. All I did was take it and rearrange it. So what I have here now is 3 f of x is equal to 3 times x plus 6 squared minus 22. which is to say 3x plus 6 squared, because I want to distribute, minus 66. Well, now that I have it in this form, I can pull out the vertex. The vertex is -6, -66. The axis of symmetry is x equals -6. And since my leading coefficient is positive, it's a minimum, right? Because it's a positive, so it's going like this. Now, some of you don't believe me, so let's graph this puppy. 3x squared. This one's going to look funky. Co Medina. 3x squared. I have no idea what was next. Plus 36x plus 42. Plus 36x plus 42. Enter. Huh? Now, we already know, we said that the vertex was -6, -66. So I know that when I set my window up, and I go to Windows, Zoom, I know that this has to be at least -12. Let's go -15 just to get an idea. My X max, we probably don't need too many positives. I can make that probably 5. But my Y min has to be at least -66, so I'm going -70. And we'll go up to 10, something like that. And hit enter, and it should be okay. Look at that. Now, I want to know what that vertex is, so I'm going to go to Menu, Trace, just for fun. Graph Trace. And hit the left, 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 left. There it is. My minimum is -66, -6, -66. And there it is. So, let's get going. So, what's this? Let me see. Let's see if I can do this. This looks like the vertex is -1, -6. So if I came down here, the vertex would be -1, -6. The axis of symmetry would be x equals -1. And it's a minimum. I don't know why. Minimum. So, now let's see if we can make this into it. So what we're going to do is bring the 5 over. So we get x squared plus 2x equals 5. We're going to add half of this. Oh, be careful. Half of this is +1. +1 squared is 1. So we're going to add 1 to both sides. Right? This side becomes x plus 1 squared equals 6. Now, if I bring the 6 back over, I get x plus 1 squared minus 6. And if I wrote this as f of x is equal like that, there's my center, or there's my vertex, -1, -6. Kind of sweet, isn't it? Now let's work with circles. Nope, not circles yet. Practice. Oh, come on, this is easy. Why are we doing this? Why are we doing this? Half of this squared, 49. Half of this squared, oh, wait a second, brothers and sisters. Half of that's 5 halves. That squared is 25 over 4. Half of this is -10. -10 squared is 100. Half of this is -12. -12 squared is 144. Notice they're always, 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 always positive. And don't be afraid of fractions. They're your friends. Normally, you don't want to do completing a square on... Normally, you don't want to do completing a square on... numbers in the middle that were odd. Oh my God, a brain fart. So what we're going to do is we're going to temporarily set this equal to 0. We're going to forget about this. So we're going to rewrite it. X squared plus 14x plus box equals -11 plus square. I don't like calling square. And I'm going to bust out my red pencil, my black pencil. Half of this is +7. Immediately I'm going to write x plus 7 squared. And x 7 squared is 49. Add 49. So I get x plus 7 squared is equal to 38. Now I'm going to bring the 38 back. I'm going to rewrite it. Y equals x plus 7 squared minus 38. So I'm bringing it back to 38, and I'm going to write it like that. So my vertex is -7, -38. My axis of symmetry is x equals -7. Now, by the way, I'm doing these for you. You probably, in class, I'm going to ask you to do them on your own. So probably what would be a good idea right now is just to pause the video, try those on your own, and then come back and fast forward and see if you got the right answer. So we're going to ignore this for now. We'll bring it back down at the end and set it equal to 0. So x squared minus 2x plus square is equal to -6 plus square. Half of this is -1 immediately. X minus 1 squared. Minus 1 times minus 1 is 1 and 1. Notice I always put plus square, so I don't even worry about the sign. It's always plus. Always, 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 always. Is equal to -5. Now, I'm going to bring the -5 back over, put it right there. It's going to be +5, but now I'm going to write it with y equals. Y equals x minus 1 squared plus 5. And I get my vertex is 1, 5, and my axis of symmetry is x equals 1. Here we go. We're moving on. Solve by completing the square. So I'll bring the 2 over. So x squared minus 2x plus square is equal to 2 plus square. Half of this is -1. Let me write that down immediately. And -1 squared is +1 and +1. So I get equals 3. Now, since I'm completing the solve by completing the square right now, I'm going to take the square root of both sides. Square root of this side, square root of this side. When you take the square root, don't forget your plus and minus. So you get x minus 1 equals plus or minus the square root of 3. Bring the 1 over, and I get x equals 1 plus or minus the square root of 3. Well, the constant's already over there, but I got to get rid of that 3 because it has to be equal to 1. Don't forget, you do both sides, not just one side, both sides when you divide by 3. So you get x squared plus 6x is equal to -1. Now I'm going to rewrite it with boxes. X squared plus 6x plus box equals -1 plus box. Half of this squared is +3. So immediately I'm going to write x plus 3 squared. 3 squared is 9. I'm adding 9. And I get equals 8. Bring my black. Let's go with blue. Take the square root. When you take the square root, you put a plus or minus. So I get x plus 3 equals. Can I go plus or minus 2 square roots of 2 without you guys crying? Remember, it's the square root of 4 times 2, which is 2 square roots of 2. Bring the 3 over, so I get x equals -3 plus or minus 2 square roots of 2. Remember, this is just 2 square roots of 2. Yay! Convert to standard form and identify the vertex. So we're going to ignore this. And we're going to go x squared minus 10x plus square is equal to, remember, we're going to set this equal to 0 and bring this over, -1 plus square. Half the middle is -5. Immediately go into parentheses. X minus 5 squared. That's a 25. That's a 25. So you'll agree with me this is really 24, right? But when I bring it back to the other side, it becomes -24. And I can throw my y back on, and I'm ready. 5, comma, 20, -24. There's my vertex. Axis of symmetry is x equals 5. So we're going to ignore this. We're going to bring it back at the end. So we bring it back. I'm bringing funky back. No, I'm bringing, I don't want to bring it. So I'm bringing funky back. Wow, that's exciting. So 0, this -10, this 10 is going to go over to this side and become -10. So I'm going to rewrite it. X squared minus 24x plus square equals -10 plus square. Bust out the red pen. That's black. We'll go with black. Half of this is -12. So immediately x minus 12 squared. 144. 144. Now, would you agree with me that this is 134? Sure. So when I bring it back to the other side, it's -134. And let's bring the y back. Vertex is 12, comma, negative 134, and my axis symmetry is x equals 12. Got one last problem, right? All right. Solve this equation by completing a square. Okay, so one of the things I'm going to warn you about is I still never, ever, 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 ever want to have that negative. Never. So the first thing I'm going to do is move it. 5x squared minus 40x. I'm going to put this in order over here too. Plus 50. Right? Minus 40. Okay. So this has to come to the other side. So we'll bring that over. So I get 50 is equal to 5x squared minus 40x. And then we're going to rewrite it. 50 plus square equals, whoa, 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 whoa. Let's back up to crazy Tane there, Krause. Forgot something. And we can do it right here. Forgot to divide by 5. You can't do completing a square unless your leading coefficient is a 1. So this is 10 is equal to x squared minus 8x. This is going to make it a lot nicer anyway. So 10 plus square is equal to x squared minus 8x plus square. Half of this is negative 4. So immediately I'm going to write x minus 4 squared. 4 squared is 16. 16. Boy, I'm really screwing up. Shouldn't this be negative 50? Negative 10? Negative 10? So 16. So I get equals 4. Take the square root of both sides. Take the square root of both sides. And I get x minus 4 equals, don't forget to put a plus or minus 2. So I get x equals 4 plus or minus 2, which, because this is not a radical, not an irrational number, I can actually do this. This is 4 plus 2, which is 6, and 4 minus 2, which is 2. So those are my two solutions. Now that begs to tell me, or screams out, that this original problem was factorable. So let's see if this original problem was factorable. I'm going to go back to the original problem. The original problem is 0 is equal to 5x squared minus 40x plus 50. Take out the 5 because I don't like to factor with that. X squared minus 8x plus 10. Guys and girls, I'm going to have to go do this problem over again because I done screwed that thing up. So, because that's not factoring. No thing multiplies to 10 adds up, multiplies to 10 adds up to negative 8. That ain't going to happen. So we made a mistake. I'm not even going to try to find a mistake. I'm going to just do it over again because I know I screwed up. And I'll tell you why I screwed up. I hate having I'm with you guys. I hate having that thing on the wrong side. So I'm going to do this a little bit different way. Maybe I need some more Brugger's coffee. All right. So I'm still going to do this. 0 is equal to 5x squared minus 40x plus 50. But I hate having the 0 on this side. So I'm just going to put the 0 over here. I can do that. All right. Now I'm going to pull out the 5, or divide by everything by 5. So I get x squared plus minus 8x plus 10 equals 0. Now I'll bring the 10 over. X squared minus 8x plus square is equal to negative 10 plus square. Half of this squared is negative 4, so I put a 16 in here. Oh, that's where I made my mistake. 16. I did negative 10 plus 16 and I got 4. That was dumb. So this is really x minus 4 squared is equal to 6. Wow, why did I do that? Crazy. How many of y'all saw that mistake? Yeah, I'll bet that freaking Goulet guy did. He's awesome. He's always picking up my mistakes. So this becomes x minus 4 equals plus or minus the square root of 6. Toss the 4 over. X equals 4 plus or minus the square root of 6. Hey, guys, that ends the lesson. Dude, I am so stoked. I get to go to school now and do more teaching with those kids. By the way, I got awesome kids this year. Awesome. Shout out to Mr. Krause's math classes because you guys rock. Most of you. Anyway, hit the subscribe button, hit the like button, hit the donate button. Need a new computer? Somehow I'm going to get a new computer. I just need one, man. I'm just kidding, man. All right, come. I love you guys. All right, have a good one. Well, I don't love all of you because that's a little weird, but I like most of you. I like y'all. See you guys. Bye.